Alright, let's look at the homework 3.5, problem number 9. Alright, so we want to find the y prime, so which is dy over dx from this given equation, and we just need to evaluate it at 1, 1 to find the slope of the tangent line at that point. Alright, so let's do that. Alright, so first thing I would do is actually I'm going to rewrite the equation just a little bit. Since you have a multiplication inside the log, we can always write it as, let's see, 5 is just a number. Then you have a natural log of x, right? Multiplication inside, we can split it as addition outside, so it's a natural log of x plus natural log of y. Alright, and this is equal to y squared minus 1. Alright, so let's take the derivative of both sides. So by taking a derivative, maybe I'll write it this way. Take the derivative with respect to x. Alright, so 5 is just a constant multiple, so we just put 5 there. Alright, derivative of natural log of x, since it's written in x, so just a regular derivative, so it's 1 over x. Alright, plus. Alright, so derivative of natural log of y would be, so take the regular derivative, which is 1 over y, but we have to multiply by dy over dx, so because this is the chain rule there. Alright, and the right hand side, if you take the derivative of the right hand side, you get the 2y, then you have to multiply by dy over dx. Again, another chain rule. And derivative of negative 1 and 0, so I'm not going to write anything down. Alright, then we're going to have this. Let's see, we want to collect all the terms that have a dy over dx. Alright, so first I'm going to just distribute 5 to both sides, both terms. So I'm going to change that to this to be 5 over x, and here 5 over y. So I just multiply both terms by 5. Alright, then let's see. I'm going to put let's see. I'm going to actually put this guy over to the other side. And we can do that by subtracting 5 over y dy over dx. Alright, so what's left on the left is just a 5 over x, and this is equal to, alright, so you have a 2y and times dy over dx. This was there already, and then you're subtracting 5 over y dy over dx. Alright, then I'm going to actually factor out that dy over dx, which can be written as, so by factoring dy over dx here and the dy dx over there, so there's a common factor. I'll factor that out and put it outside. So we have dy over dx, and what's left is 2y from here. Alright, and also negative 5 over y. So we have that, so I put that here, negative 5 over y. Alright, then we want to isolate dy over dx, so we just have to divide it through by a quantity, 2y minus 5 over y. Alright, so this is going to be, so 5 on top. Alright, so we have to divide by this guy, so it's a x times 2y minus 5 over y is equal to dy over dx. Alright, So we found that. And if you don't like having a fraction inside a fraction, you can also do this. This is not necessary, but you can multiply and top and bottom by y. Right, that way, yeah, you would have, right, dy over dx is equal to, right, so 5 times y is 5y on top. Right, there's an x here, and multiply by y, so 2y squared, and multiply by y, you get -5. Right, so we got that derivative. Right, so let's type that in first. Right, so we got 5y, so it's a fraction, right, 5y over x times and 2y squared minus 5. Right, so let's check the answer. Right, we got the derivative. Right, then we just want to evaluate this derivative at 1, 1. So let's do that. Right, so if you evaluate dy over dx at 1, 1, so we just have to plug in x equals 1 and y equals 1. So we get the 5 times y, which is 1, over, and x, which is 1, times 2 times y is 1 squared, minus 5. Alright, so we get 5 over, right, 2 minus 5, so it's -3. So answer is -5/3. Right, so let's type it in. Right, we got -5/3. Right, let's check the answer. We got that. Right, that's it. I hope that this was clear.